So welcome to the final lesson of week 3, and this is actually the last lesson we're going to do about binary integers, and there'll be the very first mini mock of the year next week when you come back to college. So make sure that you revise everything we've done in weeks 1, 2 and 3. Hexadecimal, conversion, addition, minus numbers and everything. Anyway, this last topic is called masking, and that gave me an opportunity to use a rather dramatic image of a mask, but actually it's not really got anything to do with this topic. So in this lesson we're going to learn what bitwise manipulation is and how we can use a byte as a mask over another byte. We're going to look at how the 3 operators and, or, and a new operator called XOR are used to cause masking, and quickly look at what some of the reasons we might do masking. So there's quite a lot to learn in this lesson, and it's all relatively new. It's a kind of side topic to the rest of what we've been doing about binary maths. So bitwise manipulation is a way of processing binary values that's different from addition or subtraction or multiplication or division, all those things that we've learned already. It transforms a byte by changing the bits using logic instead of maths, and it's used for encryption and for processing multimedia, for instance restoring old photos or tidying up noisy sound recordings. So there are 3 logical operations that we can carry out: and or. We're familiar with those operators because we use them in Python, and a new operator called XOR, also pronounced XOR by some people and called exclusive OR. So and is true if both the inputs are true, OR is true if at least one input is true, and XOR is true if the 2 inputs are different from each other. Don't worry, we're going to do a lot of practice with these. So we write down the byte and then we merge it using one of those 2 operators that I've just described. The second byte is called the mask. We frequently use the same mask with many different input bytes. So let's do a worked example. Here's a question. It's very much the kind of question that you might see in the exam. An AND operation with the mask 1110000 is applied to the byte 1001 1011. What is the result? Now, it's very easy to answer these questions. You just have to work methodically through it. So let's have a look at that. We write down the 2 bytes. It doesn't actually matter which way round we do it, but we typically do the byte first and the mask second, and then we're going to use the AND operator. So we're looking down each column just like we did when we were doing binary addition, but this time we're doing AND. So that's the byte, that's the mask, and if we look down each column we can see that we only write a 1 in the 2 cases where both of the bits are 1s. In every other case we write a 0. I'll look at how we might use this in real life later on, but for now let's just learn how to do it. So it's a new thing to learn, but it's actually quite straightforward. You already know what AND means. AND means both are true. And so we write them above each other. You don't even have to draw the grid, but I do it to make it easier to see what's going on. And then you just look for a match where both the values are 1, and you write a 1 in that place and all the others are 0. Here's a similar question. In fact, I've used the same mask and the same byte, but I've just changed the question so it says use an OR operator. So we write the two numbers above each other, and as long as there is at least one in a column, we write 1. And in fact, there's only one case where there's 2 zeros. There it is. And so if there's 2 zeros, we write a 0, but otherwise we fill up all the columns with 1s. Again, if you know what OR is, which you do because you've used it in Python, it's pretty easy to do this. So why might we bother with that? Well, we can use it for multimedia processing or for cleaning up distorted signals. So for example, imagine that we're getting a signal, a sound signal through wireless or through a wire, and it's very noisy. There's a lot of crackly interference on it. We might get the signal through 2 different sources and then compare them using the AND operator and only retain any noises that have come through on both signals. And because the crackles and the noise will be different, but the correct signal will be the same. So the AND operator will just clean up the signal. Or with the OR operator, supposing we've got 2 versions of a photo and both of them have got errors or missing sections, they might be ripped or something, we'd use the OR operator and it would restore the photo if it can get the bits, the pixels that make the photo from either of the 2 examples. These are just examples of how we might want to use the AND and OR operator. I don't think you'll be asked about that, but otherwise it just seems like, what is the point of doing this? Well, it is a useful way of processing data. So now let's look at our final worked example using the XOR operator. So there's a question, very typical of a question you might see in the exam. You already know how to tackle this question. You write the byte and the mask above each other, making sure that the bits line up. And we're using a XOR operator now. So if the bytes are different, we write a 1, and if they're the same, we write a 0. Let's look at a couple of examples here. Here we've got 2 zeros, so we write a 0. Here we've got 2 1s, so we write a 0. And here we've got a 1 and a 0, so we write a 1. So if you just remember what XOR stands for, exclusive OR, it means they're different from each other. XOR is actually used for encryption, and it has been for a long time. If you know the mask, you can use it to work out what the original signal was. But if you don't know the mask, you can't crack the code. So it's a really nice, simple way of encrypting messages. We're going to do more about encryption towards the end of this academic year. It's one of the final topics that we'll look at. So to recap, you've learnt what bitwise manipulation means. It means combining a byte with a mask, and we use one of the 3 operators, AND, OR and XOR, and you now know what those operators do and how to use them in masking. So here's an activity that we can do either with a friend or on working individually, depending on when I'm recording this. I don't know how the year is going to go. So write a 1-word text message, convert it to ASCII, turn the ASCII into binary, and then XOR encrypt the binary numbers using the mask that I've provided there. Now send that message to a friend and they should be able to decrypt the message. Okay, now this is the very last of a series of presentations that I've done on how numbers are represented and how bits and bytes work inside the computer. Everything we've done during weeks 1 to 3 could come up in the test, and next lesson we'll be doing that test. So be ready for it, revise everything we've done so far. All right, so I'll see you in class for the test, and then after that we're going to start looking at binary fractions, which is a whole new topic. Okay, well done for sticking with it, and I'll see you in class. Bye for now.